In the previous lesson, we learned three basic signal operations: shifting, scaling, and reversal. But what happens when we need to apply more than one operation at the same time? For example, how do we draw the graph of x of 2t plus 3? This requires both time shifting and time scaling together. We need a systematic method to handle these combined transformations correctly. Here is the two-step method for drawing x of at plus b. First, perform the shift. Draw y1 of t equals x of t plus b. This shifts the original signal by b units. Second, perform the scaling. Replace t with at to get y of t equals y1 of at. This compresses or stretches the shifted signal by dividing the time axis by a. The key insight is always shift first, then scale. If you try to do both at once, you will likely make errors. Let us apply the method to our first example. Given x of t, a trapezoidal signal that rises from 0 to 1 between t equals 0 and 1, stays flat at 1 until t equals 2, then falls back to 0 at t equals 3. We want to draw y of t equals x of 2t plus 3. Step 1. Shift. We draw x of t plus 3, which shifts the entire signal 3 units to the left. The trapezoid now spans from -3 to 0. Step 2. Scale. We replace t with 2t, dividing the time axis by 2. The signal is compressed, now spanning from -1.5 to 0. Here is another example with a different signal shape. Given x of t, a rectangular pulse with a ramp, flat at 1 from t equals -1 to 1, then linearly decreasing to 0 at t equals 2. We want to draw x of 3t minus 2. Step 1. Draw x of t minus 2, shifting the signal 2 units to the right. The key points move to 1, 3, and 4. Step 2. Replace t with 3t, dividing the time axis by 3. The key points become 1/3, 1, and 4/3. There is an alternative approach. We can rewrite x of at plus b as x of a times the quantity t plus b over a. Using this factored form, first multiply the time axis of x of t by 1 over a to perform the scaling. Then shift the result by -b over a. This means scale first, then shift by b over a. Both methods produce the same result. Choose whichever feels more natural for the given problem. What if we also need to scale the amplitude? For a transformation like a times x of bt plus c, we follow 3 steps. First, shift. Draw x of t plus c. Second, scale time. Draw x of bt plus c by dividing the time axis by b. Third, scale amplitude. Multiply the entire result by a. If a is negative, the signal also flips vertically. Let us see this with a concrete example. Consider x of t, an asymmetric triangle with vertices at -1, 0, 0, 1, and 2, 0. We want to draw -2 times x of 2 t plus 2. Step 1. Shift left by 2 to get x of t plus 2, with vertices at -3, 0, -2, 1, and 0, 0. Step 2. Compress by 2 to get x of 2t plus 2, with vertices at -3 halves, 0, -1, 1, and 0, 0. Step 3. Multiply by -2. The triangle flips and doubles, giving vertices at -3 halves, 0, -1, -2, and 0, 0. Let us summarize the combined transformation rules. For x of at plus b, shift first by b, then scale by a. Alternatively, factor as x of a times t plus b over a, and scale first, shift second. For amplitude scaling, a times x of bt plus c, shift, scale time, then scale amplitude. In the next lesson, we will explore how to construct periodic signals from basic building blocks.